Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
We are now at question 10 of this CXC CSET June 2013 General Paper 2 exam video solution. In this question, we are given a circle, center O, so this is a circle, this is the center of a circle. EBC is a tangent, that's a tangent to the circle right here at B. The angle OBA right here is 40 degrees, and angle OBF is 35 degrees. OBF right here is 35 degrees. And then now we are asked to find a number of angles in this diagram, and we have to give reasons for each of those angles. And so the first angle we're asked to find is angle EBF. That's this angle, EBF. This angle right here. So let's call it angle theta and show that angle theta on the diagram. So that's the angle that we want. Now, this line is a radius, O to B, and this is a tangent. And the angle between a radius and a tangent is 90 degrees. And what it means, therefore, is that 35 degrees plus theta will be equal to 90 degrees. And we can use that as a basis to calculate the angle theta. And this is it. Angle EBO is 90 degrees. Angle EBO is 90 degrees because that is the angle between the tangent and the radius. And this is it. The angle between a tangent EB and the radius BO is 90 degrees. And so, as I said, the sum of these two angles must be 90 degrees. So we can show that. So the 35 degrees plus the theta is equal to 90 degrees. And we can therefore subtract 35 degrees from both sides, and we end up with theta being equal to 90 degrees minus 35 degrees. And so theta is 55 degrees. And so this angle right here is 55 degrees. And so that's the answer for this part of the question. Let's go down now to part 2. Now what we have so far is that this angle is 55 degrees. And we are now asked to find angle BOA. That's angle BOA. That's the angle right here. So let's call that angle alpha and show that angle alpha on the diagram. And so angle BOA is this angle alpha. Now this line is a radius OB, and this line also OA is also a radius, and therefore this triangle is an isosceles triangle. And so the two base angles here, this angle is 40 degrees, and so this angle here must also be 40 degrees because the base angles in an isosceles triangle are equal, and we can use that as the basis to find this angle alpha. So let's state that first. Triangle OBA is an isosceles with the radius OA being equal to OB. That's what we have said. OA is equal to OB, and therefore angle OAB is equal to angle OBA. As these two angles must be equal, and they're each 40 degrees. So we can show this 40 degree angle on the diagram right here. And that's it. And now we can use the fact that total angles in a triangle is 180 degrees. So we can calculate alpha, and this is it. The total angles in the triangle OBA is 180 degrees, and therefore 2 times the 40 degree angles here plus alpha must be equal to 180 degrees. And therefore alpha is 180 degrees minus 80 degrees, because 2 times 40 degrees here will be 80 degrees. And so we can subtract that 80 degrees on this side, and therefore alpha is equal to 100 degrees. That's it. Angle BOA is 100 degrees, and that's the answer for part 2. Now let's move down to part 3. Now part 3 wants us to calculate angle AFB. Angle AFB is the angle right here. Now let's call that angle beta, and we show that angle beta on the diagram. So we now want to calculate this angle right here. Now this angle is subtended by this chord AB. This chord AB is subtending this angle here at the circumference. The chord AB is also subtending the angle 100 degrees at the center. And there's a rule that says that the angle at the center subtended by a chord is twice the angle at the circumference. And therefore this angle is half this one, or we can say this angle is twice this one. So that's the basis on which we'll find this angle beta. The angle subtended by the chord AB at the circumference F, the angle subtended by the chord AB at the circumference F, that's beta, is half the angle subtended at the center O. So what we're saying is that the angle here is half this angle here because both of them are subtended by this same chord. The angle subtended by a chord at the circumference is half the angle that the same chord subtends at the center. And therefore, the angle beta is half the angle AOB, which is 100 degrees, and that is it. Beta is half of 100 degrees, and so beta is 50 degrees. And so the answer for this part is that beta is 50 degrees. Angle AFB beta is 50 degrees. And so that's the answer for part 3. Let's move down now to part 4. Now part 4 wants us to calculate angle OAF. Angle OAF, that's this angle over here. And let's call that angle phi and show that angle on the diagram. Now what we can do, there are several ways we can find this angle, and in the solution book you'll find one method presented, and I'll use a different method in this solution. What we will do is look at the total angles in this triangle ABF. This triangle, total angle in this triangle ABF is 180 degrees, and we can use that as the basis for finding this angle phi. And this is it. Total angle in triangle ABF is 180 degrees, and if I remove the information here so you can see those angles, then the three angles in this triangle would be this angle, which is broken down into two parts, 35 and 40, and also this angle, which is broken down into phi and 40. And so the total angles inside here must be 180 degrees, and this is it. The 50 degrees up here plus the sum of these two angles here to form the angle across here, which is 35 and 40, plus the two angles across here, which is 40 plus phi to form the angle across here, would add up to 180 degrees. And so from here we see that this calculation becomes 165 degrees plus phi is equal to 180 degrees, because 50 degrees plus 35 degrees, that's 85 degrees, and then we're adding 40 more degrees, that's 125 degrees, plus 40 degrees, that's 165 degrees. So the sum of these four angles is 165 degrees, and then we're adding phi, and the result, as I said, is 180 degrees. And so to find phi, we simply subtract the 165 degrees from both sides, and so phi is 15 degrees. And so this angle right here is 15 degrees. So we can put that information back and mark that angle 15 degrees. And so those are all the angles we require to find, and this last angle is angle OAF, is 15 degrees. And so that's the answer for part 4 of question 10A, and that ends question 10A. Let's move down now to question 10B. Now in question 10B, we are presented with this diagram, and we are given a series of information relating to the diagram. Now the first thing we are told is that the points R, S, and F are on horizontal ground, and therefore triangle RSF is on horizontal ground. So this triangle here is on horizontal ground. It is an horizontal triangle, flat on the ground. And then we are told that FT is a vertical tower. That's this. FT is a vertical tower. Now remember that this line is on horizontal ground, and if this is horizontal and this is vertical, then the angle between here is 90 degrees, because the angle between vertical and horizontal is 90 degrees. Also, this line FS is on horizontal ground and this is vertical, and therefore the angle between this line and this FS also is 90 degrees, because this will be vertical. And so we can show one of those angles, and so this is a right angle triangle, and this a triangle here also would be a right angle triangle. This triangle would be a vertical triangle, and a triangle down here also would be a vertical triangle. Again, this triangle is on the ground because all 3 points are on the ground, and so this triangle is an horizontal triangle on the ground. So we see we have a 3-dimensional situation here where we have horizontal triangles and horizontal dimensions, and we also have a vertical triangle here with vertical dimensions and vertical angles. We're also told that R is east of F And if R is east of F, it means that the points R and F are on a cardinal line that runs from west to east. So this is our east-west line, west to east. And we're also told that S is south of F, and so S and F are on a cardinal line that runs from north to south. And so this is our cardinal line that runs from north to south. And remember now that the angle between an east-west line and a north-south line is 90 degrees, and therefore the angle right here is 90 degrees, and so this triangle on the ground also is a right angle triangle. We are also told that the angle of elevation of T from R is 27 degrees. So the angle of elevation of T from R is the angle above the horizontal up to the line of sight from R to T, and so that angle of elevation would be the angle up here. So we can show that angle on the diagram. That is the angle of elevation of T from R, and we can show the 27 degrees angle right there. So that's all the information we have represented on the diagram, and we can complete the diagram by joining the points S and T. So what we have is a three-dimensional situation. As I said, this triangle is a vertical triangle, and this triangle will be formed by looking up and down. If we imagine looking up and down from the foot of the tower to the top of the tower, we would form a vertical triangle, this vertical triangle here. This triangle also is a vertical triangle, and again would be formed by looking up and down. This triangle is on the ground, it's an horizontal triangle, and this triangle would be formed by looking side to side. If we look from left to right, we would form this triangle on the ground, and so it's a three-dimensional situation with two vertical triangles, this one, and one horizontal triangle. And in this case, all three triangles are right-angled triangles. The first part of this question wants us to draw separately the triangles RFT, which we said is a vertical triangle, that's this one. They want us to draw triangle TFS, that's this one, also that's a vertical triangle, TFS. And then we're required to draw triangle SFR, which we said is a horizontal triangle. And so the first triangle here is a right angle triangle. The angle here is 27 degrees, and the height of the tower here is 25 meters. So we can extract that triangle and place it here. So that's our first triangle, a vertical triangle, triangle RFT, and the dimensions are shown here. For the second triangle, which is this one, again we have these two dimensions. This height is 25 meters, and this length down here is 43.3 meters. And again, this is a vertical triangle. This line is horizontal, and this line is vertical, and so the angle at F right here would be a 90-degree angle. And so we can extract that triangle and show it here. So that's a point S, that's a point F, that's T. So this represents a vertical tower. This is the distance SF down here. And this angle, as I said, is 90. This is vertical and this is horizontal. And so the angle here is 90 degrees. And then the third triangle right here, we deduce that it's a right angle triangle as well. And it is an horizontal triangle. That's it, an horizontal triangle. And so we can extract and show that triangle as well. And so this length down here is 43.3 meters. This is the point F here. That's the point R here. That's the point S here. The distance here, as I said, is 43.3. This line SF runs north, and this line FR runs east. And so we can show our cardinal directions on this diagram. This triangle is on the horizontal ground. So that's our three triangles. Triangle RFT, which is a vertical triangle. Triangle TFS, also a vertical triangle. And triangle SFR, a horizontal triangle. Let's move down now to part 2. So these are our three triangles as we have deduced from the first part, and now we are required to find the length of RF. And to find the length of RF, we can work in this right angle triangle where we have this angle and this opposite side. And so we can say that in triangle RFT, we can use tan of this angle equals opposite over adjacent, and so tan of 27 degrees is equal to 25 divided by RF across here, and that's what we have. And so RF can be calculated from this by simply transposing and making RF the subject, and this is it. RF is equal to 25 divided by tan of 27 degrees what we have done is to simply multiply RF up here and divide the tan of 27 down here. And so we have RF equals 25 divided by the tan of 27 degrees. And when we do this calculation with our calculator, the result is 49.1 meters. And we're actually asked to show that the length of RF is 49.1 meters. And that's the answer for part 2. And so we can show those dimensions on the diagram. So that length is RF, and note here that this distance also is RF. So we can also show that distance on the diagram. RF is 49.1 meters. Let's move down now to part 3. Now part 3 is asking us to find the length of SR. That's this length right here, SR. So we can use this triangle to calculate the length of SR using Pythagoras' theorem. And so let's show that. Using Pythagoras' theorem in triangle SFR, we see that the length of SR will be equal to the square root of this side squared plus that side squared. That's using Pythagoras' theorem. And when we do that calculation, the result is 65.5 meters. And so we can show that 65.5 meters on the diagram, and that's it. SR is 65.5 meters. And that's the answer for that part. Let's move down now to part 4. Now part 4 wants us to find the angle of elevation of T from S. That's the angle of elevation of T from S. Remember that this is horizontal, SF is horizontal, and that's our vertical tower. And so the angle of elevation of T from S would be the angle above the horizontal here. And that's it. We can show that on the diagram. Let's call that angle theta and show that angle on the diagram. So that angle will be the angle of elevation of T from S, and we are calling that angle theta, and we can use the tan of this angle equals opposite over adjacent. Tan of theta equals opposite divided by adjacent in this right angle triangle to calculate that angle theta, and this is it. Tan theta is 25 divided by 43.3, and so theta is tan to the minus 1 of 25 divided by 43.3. And when we do this calculation, our angle comes out to be 30 degrees. And so the angle of elevation of T from S is 30 degrees. And so that's the answer for part 4 of question 10b. And that's the answer for question 10. And we'll do question 11, our last question, in our next video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.